All right, now we're going to look at 2D motion equations. All right, so what's different about two-dimensional motion is I have both an x and a y that's happening simultaneously. But a lot of the other stuff stays the same. So in order to get from a position function, which is now described as an r, to get to a velocity function from a position function, I still take derivatives. From velocity to acceleration, still taking derivatives. And to go back, I still take integrals. And when I take those integrals, I still need that additional information, like things like starts at the origin, or tell me about a velocity at a certain time, or position at a certain time, some sort of initial condition or condition. So I'm just going to show you what this looks like in 2 dimensions, and I'll give us a couple examples of some other things that stay the same. So here I have a velocity function where velocity is measured in meters per second, time in seconds, and I want to get a position function from it and an acceleration function from it. So to get an acceleration function from it, I'm going to have to take the derivative. Now when I take the derivative, dv dt, I'm going to take the derivative and I'm going to think about those I and j hat things as separate functions. This is a function in my x direction. This is a function in my y direction. So the derivative, oops, that's an I, by the way. The derivative of this is just 2, and then I get I hat, and the derivative of 6 is 0, so I get 0 j hat. And so that's how I do it. Another way you can think about these functions is you could think about this as an x function, or an x component if you want to use that idea, an x function of 2t minus 1 and a y function of 6. And you could then take those derivatives and you have an acceleration of 0 in the y direction and an acceleration in the x direction of 2. And then you could put that back together and get an acceleration of 2 I hat plus 0 j hat. Either way is acceptable. Now let's take the integral of this to get a position function. Okay, so I'm now going to integrate with respect to time my velocity function. And so my position function, I'm going to end up with t squared minus t. But I also have to have an initial condition, so I'm going to have plus something. Now, because this is inside that I hat, this plus something is my initial x position. Okay. Plus, in the y direction, I'm going to have 6t plus a y initial. So each of these is going to have an initial condition because I'm thinking about these as 2 separate functions. So they're going to have 2 separate c values. If you want to think about it as a single c value as having components x naught and v naught, that's fine. But also think about it this way. All right, some other things that are still the same. When we want to find the displacement, so delta r, I'm still doing the final minus the initial. Or to find the displacement, I can take the definite integral from t1 to t2 of my velocity function as well. Okay, so either one of these will work just the same as we did last chapter. We're still doing these kinds of things. Or v average. V average is going to be my displacement, which I could find either way, divided by my time. It's just now I'm going to have components in the I hat or j hat direction. Now, something to keep in mind about 2 dimensions. Here I have it in these rectangular situations of I hat and j hat. But I could also put this into a more polar type of problem. So you can think about anything as having a magnitude, say 20 meters, and a direction, say 30 degrees, counterclockwise of the positive x-axis. And from here, I could break this down, resolve this into, this might be my r vector, into components. So it will have 20 cosine 30 and 20 sine 30. And so this would look like 20 cosine 30 I hat plus 20 sine 30 j hat. So I could talk about it as 20 meters at 30 degrees counterclockwise of the positive x-axis, or I can talk about it as this I hat j hat. Either one is acceptable. One is in more of a polar form, one is in a rectangular form if you want to think about coordinate systems. We usually call this a magnitude and direction when we talk about 20 meters at 30 degrees, and we talk about this one as component form.